chapter 13. Okay, number one, we know we're looking between 270 and 360, so that puts us in the fourth quadrant. So I'm just gonna draw a terminal side in the fourth quadrant, connect it to the x-axis. Here's the reference angle. That's going to be our theta. So they're telling us sine is -5/7. So that's opposite of our hypotenuse. Opposite, they don't have to be the -5. The hypotenuse is 7. They're asking about the cosine of that angle. So I would want to know the other side. So we use Pythagorean theorem. So I can throw out the negative now. 5 squared plus x squared equals 7 squared. So we get a 25 and a 49. Subtract that 25 away, we get 24. Square root of that, square root of 24, I can pull out, if I factor tree that, I can pull out a 2. So a 2, 2, and then a 2, so there's 6 left. So 2 square root of 6. Since it's to the right, it is positive. So now cosine of that, adjacent or hypotenuse, 2 square root of 6/7. So D is the correct answer. Number 2, so here they're looking at the third quadrant. Okay, sine, so that's opposite, -11/15. So Pythagorean theorem again, 11 squared plus x squared is equal to 15 squared. That's 121. 225. So 104. We've got a square root 104. So we can pull out a 2. Let me think here. So it'll be a 26 that's left over. So that's obviously that's not right. What am I? Maybe it is. Maybe I just have to simplify. 104 divided by 4 is 26. Yeah. Okay. So let me try this. That would be the side up here would be -2 square root of 26. Still don't think that's right. I must have made a mistake. Oh, okay. I'm just assuming they're going to use that side. Maybe they're not going to use that side. They're asking about cosecant. Cosecant is the reciprocal of sine. So I actually didn't even need to do all that work, because here was sine, cosecant, it's reciprocal, so it'd just be -15/11. So we didn't even need to use that adjacent side, which is why I wasn't seeing the square root of 26 up there. Number 3. Okay, so we're going to use trig identities. Trig identities, it'd be worth right away, before we get too far into it, make sure we get a list of all of our Pythagorean identities. So I'm going to do that right here, and I'll kind of keep pulling this up as necessary. But sine squared of x plus cosine squared of x equals 1. That's one we should all have memorized. Then to derive the other two, start by dividing everything by sine squared. Sine squared divided by sine squared would be 1. Cosine squared divided by sine squared, that's cotangent squared. 1/sine squared, that's cosecant squared. Okay, now go back up to the original and divide them all by cosine squared. Sine squared divided by cosine squared, that's tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. So we'll kind of refer back to this, but on this particular problem, we're doing 1 minus cosine squared. If we look at this top one, if we take 1 and we subtract cosine squared from it, I get 1 minus cosine squared. The other side is just sine squared. So that's what that denominator is. So I get 1/sine squared. Then to simplify that, I want to bring the sine squared up, so we have to reciprocate it. The reciprocal of sine is cosecant, so it would be cosecant squared. So that would be A. From there, number 4, find secant. So this goes back to drawing our picture now. So 180 to 270, that's going to be a quadrant 3 triangle again. Tangent is opposite over adjacent. So opposite over reference angle is 1. Adjacent is 4. They want us to find secant, so I would do Pythagorean theorem with 1 and 4. So we get 1 plus 16, 17. So 17 is equal to c squared. So c would have to be square root of 17. And so it's asking for secant. We know secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse, square root of 17 over the adjacent, which would be the 4. Square root of 17 over 4 is h. Now, actually, one thing I should take into account here, because I actually think I probably circled the wrong answer. 1 and 4, they were actually both negative. Since 4 went to the left, I know that's a negative. Since 1's down, it's a negative. The reason it was listed positive here, because I had a negative over negative is positive. But in this case, I'm only using one of them. So I'm using the negative 4. So it actually should be negative square root of 17 over 4. So it should have been J, not H. Careful with those signs. Number 5, I'm going to draw a picture 90 to 180. Is second quadrant. Sine of that reference angle, opposite is 3, 5. That's a Pythagorean triple. You could do Pythagorean theorem if you need to, but I know it's a 4 because 3, 4, 5 make a right triangle. They want cosines, that's adjacent over hypotenuse. Let's think about sines. This 4 does need to be negative. Since it's to the left, the 3 was positive, that part's right. But adjacent over hypotenuse, it's negative 4 over 5, so that's B. Number 6, now I go back to identities. I have 1 minus cosecant squared. Cosecant squared shows up in the second one. If I rearrange this, 1 minus cosecant squared, I have to subtract cosecant squared over. But in the process, I'd have to get rid of cotangent squared, so I would subtract it away. So it would be a negative cotangent squared. So that's what my numerator is. Negative cotangent squared of, I guess it's theta, over cotangent squared of theta. So cotangent squared of theta over cotangent squared of theta will cancel out, so I'll be left with a negative 1. It's F. Number 7, look there in the parentheses, secant squared minus tangent squared. Look at this bottom one, secant squared. If I subtract tangent squared away, it'll be secant squared minus tangent squared equals 1. So that's what goes in my parentheses. So I have negative 4 times 1, which is negative 4D. Number 8. Let's see. So we have addition, subtraction situations. Maybe the first step I'll do is I'm going to move this cotangent squared up to the numerator by making it tangent squared. So we have tangent squared of theta plus cosine squared of theta minus secant squared of theta. Now let's take a look at our identities, see if any of them have 2 of those 3. I do see that tangent squared and secant squared show up in the same identity. Notice the secant squared is negative. And if I had tangent squared minus secant squared, I have to subtract it over. Then I would have to subtract the 1 over. So I would end up with tangent squared minus secant squared is equal to negative 1. Well, I can take these out of order and do tangent squared minus secant squared, and that part is equal to negative 1. So I can replace that with negative 1, but I still have cosine squared of theta there. So I have negative 1 plus cosine squared of theta, or also that could be called cosine squared of theta minus 1. So look up here, cosine squared minus 1. If I subtract the 1, I have to subtract the sine squared over. I get negative sine squared of theta. That would be my answer. Negative sine squared of theta is F. All right, next question. Which expression is equivalent to 1? Well, as I look at letter A, there's no squares here, so I can't use any Pythagorean identities. I can't cancel out the signs. I mean, I could make 2 different fractions, 1 over sine theta plus sine theta over sine theta. That part becomes 1, but then this is still a cosecant. Cosecant theta plus 1. That doesn't look like it equals 1, so we're probably going to throw A out. Let's check B. Tangent squared minus secant squared. So tangent squared minus, I'd have to subtract the secant squared over, but then I'd have to subtract the 1 over, so it'd be a negative 1. So that's equal to negative 1, not quite positive 1, although it got pretty close. Okay, let's check the next one. I'm going to bring secant squared up, so that's cosine squared of theta. Bring cosecant, that's sine squared of theta. Cosine squared plus sine squared? Oh, look, cosine squared plus sine squared is 1. Looks like there's our answer. Just to confirm, let's check D also. And probably move secant up. So there's no denominator. So it would become cosine. Maybe I put them all in terms of sine and cosine now. So cosine over sine is what cotangent is. Cosecant is 1 over sine. So I'm going to end up with cosine squared over sine squared, which is cotangent squared, which is not 1. So C it was. All right, and that's the end of chapter 13.